Hi guys, let's start numericals from exercise 5a. This is your chapter on upthrust, Archimedes principle and flotation. Before we start, let's quickly revise the theory that you would have already done. As far as this exercise is concerned, there are three basic formula or maybe a basic concept that we'll use. We know density is equal to mass upon volume. We've been doing this since maybe grade 6 or 7. Number two, we know upthrust, which is the force applied by a liquid or rather a fluid on any object which is immersed in it, is equal to the volume of volume of solid which is immersed, the part of the solid which is immersed in the liquid multiplied with density of the liquid multiplied with gravity. So upthrust is equal to volume of solid which is immersed in the liquid multiplied with density of liquid multiplied with gravity. And number three, which is apparent weight, would be equal to the weight in air minus weight in fluid, whichever fluid we're talking about. So most of the questions here would be based on a liquid, so that's why I was using fluid and liquid interchangeably, but upthrust is basically on any fluid. So let's look at a question. Question 1. A body of volume 100 centimeter cubes weighs 5 kgf in air. So this is centimeter cube and this is kg, which means I'll have to convert either kgf to gram force or I have to convert centimeter cube into meter cube. Let's convert centimeter cube into meter cube. So volume is equal to 100 centimeter cube, which is equal to 100 upon 10 to the power 6 meter cube, which is equal to 10 to the power negative 4 meter cube. So that's the volume of solid. Next, completely immersed in a liquid of density 1.8 into 10 to the power 3. So density of liquid is equal to rho liquid, which is 1.8 into 10 to the power 3 kg per meter cube. Next, find upthrust due to the liquid. So we know upthrust is equal to volume of solid multiplied with density of liquid multiplied with g. In this case, 10 to the power minus 4 multiplied with 1.8 into 10 to the power 3 into g, which would mean I'll convert this into kilogram force. So this is 1.8 into 10 to the power negative 1, which means 0.18 kilogram force. So that's the answer. The upthrust due to liquid is 0.18 kilogram force. Next, part 2 of the question. So this is part 1 answer. Part 2 of the question says weight of the body in liquid, which means we're talking about the apparent weight, which means weight in liquid would be equal to weight in air minus upthrust. So weight in air is given equal to 5 kgf minus upthrust we just calculated as 0.18 kgf. So this will be equal to 4.82 kgf. So weight in liquid is 4.82 kgf. Very simple. Let's look at the next question. The next question says a body weighs 450 gram force in air and 310 gram force when completely immersed in water. So these are simple ones where they are completely immersing it in water, which means upthrust on the whole body is equal to the upthrust on the immersed part. So let's just write the information given. Weight in air is equal to 450 gram force. Next, weight in water is equal to 310 gram force. Find the volume of the body, loss in weight of the body and upthrust on the body. So loss in weight is basically equal to weight in air minus weight in water, which means 450 minus 310, which is 140 gram force. So that's part 2 of the question. Let's look at upthrust. So upthrust is basically equal to the loss in weight. So that is also 140 gram force. So upthrust is equal to loss in weight, which is also equal to 140 gram force. So that's our part 3 of the question. That brings me to part 1 of the question, which is volume of the body. So we know upthrust is equal to volume of solid multiplied with density of liquid multiplied with G. Right, this is in any case in gram force, so that makes our life simple. So upthrust is given, we just calculated as 140 is equal to volume of solid, we don't know, and density of liquid, since density, this is water, density of water is 1, therefore volume of solid is 140 centimeter cube. Since density of water is equal to 1 gram per centimeter cube. You need to keep it in mind, since we're talking about all the elements were gram force, that's why I have taken it in 1 gram per centimeter cube. If this was kgf, then density of water would have been taken as 1000 kilogram per meter cube. That's something that you need to keep in mind, and you will need to remember the density of water. Let's look at the next question. The next question that we do is question number 3. In fact, we'll be doing all the numericals here. Hollow iron ball A of volume 15 centimeter cube and mass 12 gram, and solid iron ball of B of mass 12 gram. Both are placed on surface of water contained in a large tub. Okay, so let's talk about for A and this for B. Mass is 12 gram. Mass of B is also 12 gram. Volume of A is 15 centimeter cube. Volume of B is not given. Density of B is given as 8.0 gram per centimeter cube. Density of A is also the same, which is 8 gram per centimeter cube. Next, find upthrust on each ball. So upthrust would be equal, upthrust on A would be equal to volume, which is 15, multiplied with density of water, which is 1, multiplied with G. So this is 15 gram force. So upthrust on ball A is 15 gram force. Let's calculate upthrust on B. For that, we need to find the volume. We don't know the volume, but we know density is equal to mass upon volume, which means volume is equal to mass upon density. Mass is 12 gram, density is 8 gram. So this is 4 into 2, 4 into 3. So this is 1.5 centimeter cube. So volume of B is 1.5 centimeter cube. So upthrust on B would be equal to volume, which is 1.5, into density of water, which is 1, into G. This is 1.5 gram force. So upthrust on B is 1.5 gram force. So we've calculated upthrust on each ball. Next part of the question: which ball will sink and which will float? So let's check. If the upthrust is more than the weight, then it will float. If upthrust is less than the weight, then it will sink. So let's calculate the weight here. So weight of A, this is in air, would be equal to 12 gram force. This is weight is equal to mass into gravity. So basically 12, which means 12 into gram force. So this is 12 gram force. And weight of B is also equal to 12 gram force. Again, weight is equal to mass into gravity. Now in this case, case 1, where hollow ball, it will float because the upthrust is more than the weight. So since for hollow ball A, upthrust is more than weight in air, ball A will float. For case 2, since for solid ball B, upthrust is less than weight in air, ball B will sink. I hope you understand that when the balls are floating, so in this case when the ball is floating, the whole of the ball will not be under the uh, surface of liquid, only some part will be. That's why you are getting the upthrust being more than the weight of ball, which can never be happen. Which can never happen. Upthrust is equal to the volume of the solid under the water. So in this case, under the water, we don't know. That's why we've calculated the upthrust on the full volume. When we do exercise 5C, this concept will become slightly more clear. Let's move on to the next question. The next question that we do is question number 4. A solid of density something. So point number 1, density of solid is equal to 5000 kilogram per meter cube. Number 2, weight is equal to 0.5 kgf. It is completely immersed in water of density 1000 kg per meter cube. So we'll need to calculate the volume. So we know density is equal to mass upon volume, which means volume is equal to mass upon density, which is, so if weight is this much, mass will be equal to 0.5 kg. And that's why we're getting the weight as 0.5 kgf. Weight is equal to mass into gravity. That's why it becomes gravity gram force. So 0.5, in this case kilogram force. So this is kilogram force and this is 0.5 kg. So mass is 0.5 kg. The volume, or rather the density, is 5000 kg per meter cube. So the volume becomes 0.5 divided by 1000, which is 10 to the power negative 4 meter cube. 1, and this becomes 10. This is 3 more 0. Yes, that's correct. 10 to the power minus 4 meter cube. Next, calculate apparent weight. So for that, first we'll need to calculate the upthrust. So upthrust would be equal to volume of solid, which is 10 to the power minus 4, multiplied with density of liquid, which is 1000, multiplied with gravity. In this case, it would be equal to 10 to the power minus 1, which is 0.1 kilogram force. Right, 0.1 kilogram force. So apparent weight would be equal to real weight, or rather weight in air, which is 0.5 kgf, minus upthrust, which is 0.1 kgf, which is 0.4 kgf. So the apparent weight is equal to 0.4 kgf, kilogram force. Let's look at the next question. The next question that we do is question number 5. So question number 5 says, two spheres A and B, each of volume 100 centimeter cube, are placed on water of density 1 gram per centimeter cube. Sphere A is made of wood of density something, sphere B is made of iron of density something. Find weight of each sphere. So for sphere A and for sphere B, point number 1, volume of A is 100 centimeter cube. Volume of B is also 100 centimeter cube. Next, density of A is given equal to 0.3 gram per centimeter cube, and density of B is given as 8.9 gram per centimeter cube. We need to calculate the weight, which means we need to calculate the mass. We know density is equal to mass upon volume, which means mass is equal to volume into density. Therefore, mass of object A, in this case sphere A, is equal to volume, which is 100, multiplied with density, which is 0.3, which means this is equal to 30 gram. Therefore, weight of A would be equal to 30 gram force. Yes, that's correct. Similarly, let's calculate the mass of B. Mass of B would be equal to volume multiplied with density, which means 890 gram. Therefore, weight of B would be equal to 890 gram force. You can figure out how much difference density makes. Volume is the same. Object A weighs 30 gram force, object B weighs 890, almost 30 times that. So we've calculated the weight of each sphere, upthrust on each sphere. So for A, upthrust would be equal to volume, in this case 100, multiplied with density of liquid, which is 1, multiplied with G, which means upthrust A would be equal to 100 gram force. Let's calculate upthrust B. Upthrust B would be equal to volume into density into G, which means upthrust for B would also be 100 gram force. So basically, we figure out that the upthrust has got nothing to do with the mass, it is dependent on the volume. So the volume of solid under the liquid, in this case, volume of solid under liquid, we've taken as the full volume of 100 and 100. So it depends on the volume of the solid, density of the liquid. Since both volume and density were equal, upthrust for both of them is exactly the same. Which sphere will float and why? Again, the same concept. Since upthrust on A is more than the weight of A, therefore A will float, and since upthrust of B is less than weight of B, therefore B will sink. Perfect. That brings me to an end of this video. I'll see you in the next video. Take care, be safe, bye bye.